Today we're going to talk about theoretical and experimental probability. Theoretical probability is what we've been doing all this whole time, and we're using math formulas to find out the probability of an event. So if we're finding the probability of an event, and this should already be in your notes, this part, the number of favorable outcomes is divided by the number of possible outcomes. And this is what we've been doing this whole time. So, for example, if you toss a coin, it will either land on heads or tails. So the theoretical probability of it landing on heads or tails is 1/2, because if it lands on heads, that's one favorable outcome out of two possible outcomes. So the probability of landing on heads is 50% and landing on tails is 50%. But if we're looking at experimental probability, this is when we're actually making an experiment. So if we repeat an experiment a number of times and then we observe its outcomes, this is our experimental probability. So the probability of event is the number of times the event occurs, and that's divided by the total amount of trials. So if we're flipping a coin and we flip it 10 times, then we see that it lands on heads 3 times. And then that means the probability of getting a head between heads or tails would be 3 out of 10, because that's what we got in our experiment, which is 30%. So if we got heads 3 times, then that means we got tails 7 times. So the probability of getting tails in this experiment was 7 out of 10, which is 70%. Notice that this is different from the theoretical probability, because that was 50% for heads and for tails. But this one's a little bit different because the experiment happened and we got a little bit of a different answer. Oops. So for theoretical, here I have in this cup, I have 3 red blocks, 3 red blocks, 2 yellow blocks, and 1 blue block. As it says here, 3 red blocks, 2 yellow blocks, and 1 blue block. And we're going to find the theoretical probability of getting a red, yellow, or blue. So if I have 3 red blocks, then the number of favorable outcomes of pulling a red would be 3. And we're going to divide this by the total amount of outcomes, which is 3 plus 2 plus 1, 6. So 3 over 6 can be simplified to 1/2. So the probability of getting a red is 1 out of 2. The probability of getting a yellow, there's 2 yellows, so 2 favorable outcomes out of a total of 6. So 2 out of 6 can be simplified to 1/3. So the probability of getting a yellow is 1 out of 3. And the probability of getting blue, well, there's 1 blue block, so 1 favorable outcome out of a total of 6 outcomes. So the probability of getting blue is 1 out of 6. This is our theoretical probability. But let's actually perform an experiment. We're going to actually perform an experiment, and I'm going to pull a block out 6 times. And I'm going to record, is it red, yellow, or blue? So let's go ahead and perform our experiment. I got a red. I'm going to put this right back into the cup so they all still have an equal chance. So I'm going to put a little tally mark next to red. Got another red. Another tally mark next to red. Oops. Got a yellow. Tally mark next to yellow. I got a red for my 4th trial. The code word is blue Christmas tree is the code word. I pulled a yellow, and so I put a little tally mark next to yellow. And I'm not looking, so this is still really random. I'm not looking into the cup, so it's still pretty random. And I pulled out another yellow for my 6th trial. Okay, so I just performed this experiment 6 times, so that means 6 trials. In this case, I got 3 red, 3 yellow, and 0 blue. So for the experimental probability, the probability of getting red 3 times it occurred out of a total of 6 trials, so 3 out of 6 equals 1/2. And the probability of getting yellow was 3 times out of 6, which is 1/2. And the probability of getting blue, that happened 0 times out of all 6 trials, so 0 out of 6. Remember, if 0 is our numerator, 0 divided by a number equals 0. So 50% of the time I pulled out red, and 50% of the time I pulled out yellow. And just take note that this is different than theoretical. Well, we're asking ourselves, how come I do not get a theoretical value when I perform an experiment? And this needs to be in your notes too. If you repeat the experiment many, many times, then the closer you will get to the theoretical value. So if I just perform that experiment 5 million times, then I would be really close to the theoretical value. Maybe not exactly, but the more times you do it, the more closer you would get to your theoretical value. And again, this needs to be in your notes.